Okay, so now we're going to bring all of that together and find an actual slope value. Okay, we haven't really done it yet. An instantaneous slope value. We found the average rate of change, which was, could be used as an approximation, but we want to find the actual instantaneous rate. We want to find that f prime of a. All right, that's our goal. So I love this. Although the slope of a curve is always changing, we know the slope of any line is constant, even our tangent line. So let's apply the limit rules to our rate of change. All right, we want h to go to 0. All right, now, of course, it can't. So, though, if we did send h to 0, those 2 points, that p and that q that were on the previous thing here, would come together and be the exact same point, and you would have the slope at 1 point. Okay, that's our goal. All right, but you can't substitute 0 in, because if you did, you have 0 over 0. But you know that, and we've seen it a million times, that if you do have a 0 over 0, there's probably some sort of algebraic technique we can use to evaluate the limit. Oh my gosh, that's exactly what she says right here. We can use our algebraic techniques to evaluate the limit. Haha. Okay, so that's called the difference quotient. This is called the limit, and that is the slope. This is actually equal to, and we can go ahead and write it right now. I'm going to go ahead and say it. This is equal to f prime of a. That's at the derivative at a particular point. The derivative at a particular point. All right, that's what we're going to do. All right, now, okay, so the next example then is just kind of practicing doing this substitution. It's kind of an algebra thing, but it's fine. It gets us heading in the right direction. Okay, honestly, I've never thought to do this part, but then we can build on it for the next example. Okay, so it's fine. Kind of taking baby steps a little bit. So what it's asking you to do is not to find at a particular point or anything. Just find out what f of a plus h is and what f of a is. That's all we're doing. Okay, so it's like it's getting us ready. So like this would be y2, this would be y1. So it's getting us ready to use those two things. Okay, so I kind of like that. It's incremental. It's good. All right, so f of a, which is going to be, y1, all right, you could really think of it that way. I'm actually going to write it. All right, so y1 on your slope, on the difference quotient, is going to be f of a. She's not going to say anything about that, but I kind of like it. So all that is x changed to a. Okay, so that'd be 1 over 2a. And you're like, is that all there is to it? Yeah, that's all there is to it. Okay, but y2 is a little bit more complicated. So y2, which is the first thing that we would subtract from. So that would be f of a plus h. Now, be careful here, because what's happening is the x is changing to a plus h, and the x was multiplied by 2. Let me write that this way first. You'll see that? So x, what used to be x, is now a particular value in this one. And then this is a particular value plus that incremental value of h, whatever, typically a very small amount. But it could be whatever. It doesn't matter. So then if you wanted to clean that up just a little bit, you could. I mean, this is fine. But, if we actually had to do some work with it, which we will, then we need this to look a little bit better. That's it. Okay, so for part A, that's all they wanted you to do is write out what f of a is and f of a plus h. And then we would throw them into the difference quotient and send h to 0 with some sort of algebra. Okay, all right, what about this one? All right, so on this one, we have f of a. All that's doing is changing x to a. I mean, literally, that's all that happened was x changed to a. So let's do that. And you're like, what is this doing? Well, there's going to be some algebra involved. Okay, it is. And then, as we've said before, you'll have some shortcuts. This is the way this works. That's why it's user-friendly for humans. So then for the y2, on down the line a little bit, we're changing a to a plus h. So changing a and x, actually, x to a plus h. So, again, if you want to, I mean, it's probably fine like that, but I'm just going to go ahead and distribute there. So I have 3a plus 3h minus 2, and there we go. So I bet you she leaves it like that. But either way, we're good. Okay. All right. A couple more like that. I'll go a little bit faster this time. So f of a is just changing x to a. And again, this is using our slope or average rate of change formula. And then going to send h to 0 at some point. Now this one, we definitely want to clean up a little bit because, what's going to happen is we're going to have some like terms and stuff that would combine and that kind of stuff. So we would want to clean that up as much as I can. So this is 2a plus 2h, right? Just going a little bit faster here. All right, minus not x squared, but a plus h squared, which then needs to do FOIL method or box, whatever it is. I think most of you guys did FOIL when you learned this the first time a long time ago. But that's what I'll do too. All right, be careful here because we're subtracting all of these things. Okay, and then distributing the -1, which you could have done previously if you so desired. So 2a plus 2h minus a squared minus 2ah minus h squared. Woo! All right, so that one was a doozy. Okay, and then on this one, we would have f of a is just x changing to a. That's the one everybody likes because that one's real quick. And this one's not going to be too bad anyway because that squaring over there is what caused us a little bit of a headache, but it wasn't bad. Okay, so there's f of a. And again, I like to think of that as y1, all right, on your average rate of change formula. And so then there's not a lot I can do here. There's not going to be any distributing. All it is just that x is going to change to a plus h. That's all that's going to happen. So I'll have 3 over, not x anymore. Now it became a plus h, so that you can move on down the line a little bit and get you an actual slope, and then try to bring those 2 points together. All right, so that's it for example 3. All right, I like that. Okay, it's good. Kind of wish I'd thought about doing that years ago. All right, it's going to help us build.